Hello and welcome. This video we do a number patterns question from the IEB exam in 2023 paper 1, and it's really such an interesting question, and quite an interesting way to ask something to do with a quadratic sequence. So let's read the question together. So what we have here is, for a quadratic sequence the following information is given, and we've got pieces of information that are provided to us. So we're being told that T2 minus T1 is equal to 4. And we also know that T3 minus T2 equals to 7. And we also know that T10 is equal to 0. 3 pieces of information there. And the question is asking us to find the nth term of the quadratic sequence. Now, before we do this, I'm going to ask you, well, probably start by attempting to do this by yourself before you watch the rest of the video. So you can pause right here and try it, and then come back to the video after you've done your attempt. Okay, so this is a 5 marks question, and it's 5 marks. I would say it's a little bit complex because it's not a straightforward asking. It's not going to ask you straightforward. It's not asking us a straightforward quadratic sequence that we know. um, so what we need to do here is, let's try and analyze what is given to us over here. One of the things you'll notice is there's a T2 and T1 there, and then there's T3, and T1, T2, and T3 are consecutive. So maybe you could write them down like that so you can sort of really analyze that visually. So you could go T1, T2, T3. And there's also T10, which is obviously much after these three, so we can just put it somewhere there, T10. Which T10, we know that one is equal to 0, but we'll deal with that later. So now we can find the differences here. Clearly, this has been given to us, so that's 4, and that's given from the green piece of information that's provided. And we are also given that this is 7, and we get this from the red piece of information up there. So we can tell that at least, and this is sort of putting it together visually so we can see it like that. Now, one of the things we know about the quadratic sequences is that you could find the second difference, and this is what you typically want to do most of the time, so that you can say 2a is equal to that second difference. So once we have this, it would be smarter to find the second difference as well, which would be 3 in this case. And what we know is that this position in a quadratic sequence is always equal to 2a. And that position in a quadratic sequence as well is always equal to 3a plus b. And that position is always equal to a plus b plus c. And obviously these a's and b's and whatever and c's are coming from the actual nth term, which we're trying to find, right? So these Tn equals an squared plus bn plus c. That's really what we're trying to find, remember, at the end. So we want to start here at the bottom. You can see at the bottom you've got enough to find a. So if you go 2a equals 3 there, you'd be able to find a, and that's great. So let's go 2a equals to 3. This tells us that a is equal to 3 over 2. And we're making progress because now we know a is 3 over 2, which we're going to put there, but not yet. We still have to find b and c as well. Okay, so to find b, we can now move on to the 3a plus b, which is equal to 4. So instead of a, we would replace with 3 over 2 because we now already know what a is. So that's going to be like this. And this means b is equal to 4 minus 9 over 2. And b is, in the end, negative half. Okay, so now we have A and we also have B. So this is great progress. We just need C. We don't know what C is. Um, and and this is where if you're not careful, this is where you're probably going to get stuck because you don't really know T1. On a typical quadratic sequence, we are usually given T1 and we just typically go and take A plus B plus C. And by this time, we already have A and B, and we just sub that in and find C. But the problem is we don't have T1 in this situation. So this is not going to work. The A plus B plus C is not going to help us. Rather, we need any term that's available to us. And I guess that's why T10 was given. This is where we're going to be able to take advantage of the fact that we know T10 is 0 and use that to solve for C. So that means we're going to need to start by saying what T10 is, obviously using the general term T10, just using this at first. Let's just start off using this to see if we put 10 in the place of n there, what happens? What does it look like? So it's an squared, so it's a bracket 10 squared plus b times 10 plus c. And we can simplify this a little bit. So this is T10 is equal to 100A plus 10B plus C. And what we know now, we can obviously we know A, we also know B. We mustn't forget that we already know those two things. And you know what? We also know T10. That's the whole point of us doing this anyways, because we know T10. So we're going to change T10, which we know it to be 0. That was given to us. So we're going to say now 0 is equal to 100. A is 3 over 2, as we know it from the previous calculations. 10 is negative half plus C. And if you do add these numbers up together and move things around, you should find out that C is equal to negative 145. And this means in the end, your Tn is the same as 3 over 2 n squared minus 1 half n minus 145. And that's exactly how you do it. So So, so as the question is given, it seems a little bit complicated, but as you put it together like this, so you can visually analyze it, it becomes a little bit more accessible. But then you get stuck towards the end when you don't have T1, and if only you remember that T10 is there, then you are able to finish this entire question. So thank you for watching this. Hope to see you in the next one. Have a beautiful day.